Today, folks, this is tutorial number 7, video number 7 on the motion design, the dynamic aspects of it, and it's from 3D Experience Release 2025x. It's a very simple problem, a mass spring damper system, and the configuration is shown here. I'm going to be modeling the left fixed wall as a block, which is going to stay put in space. And then there is a block of certain dimensions on the right side, and that's attached to the spring. And the free length of the spring is 0.5 meter. The mass is 40 kilogram, and the force applied is 100 Newton. And these two, the length of the spring as it will be modeled, the separation between the two the block and the wall, is 0.5. That means that it is the unstretched length of the spring. In other words, no load was applied there because of the fact that the free length is 0.5 and the separation between the two things is also 0.5. There won't be any movement. However, that's when you apply a force, of course, then movement will take place. I'm going to do it with and without the damping. See that the sides, the size of the block is 0.1 meter on each side. Let me remind you that in order to get the spring element and damper and bushing, you have to go to the machine elements tab, and there it is. When you click on it, you get the dialog box here. If it's your axial spring, it's the one on the left. If it's a torsional spring, the one on the right, but ours is axial. So notice that what I'm doing is I indicate that the free length of the spring is 0.5 and the spring rate is given in the statement of the problem, 100 Newton per meter. And of course, when there is no damping, this is 0. When there is a damping, which is going to be one of our cases, just put the damping coefficient there. Now, I've done this thing analytically. It's a very simple problem that can be solved in any vibrations from any vibration textbook. And the displacement of the mass as a function of time without the damping is shown here. And with the damping is shown right there. Okay, so let's go ahead and solve the problem. All right, let's start with an assembly. Notice that this problem, I can create a prismatic joint between the block and the wall, and that's exactly what I'm going to be doing, but can also be done without a joint. Then, of course, you have to deactivate the gravity if it's in the wrong direction. But anyway, we're going to create a prismatic joint. So let's do the wall first. Insert 3D part, and let me change the name of this, properties. I'm going to call this thing, this is going to be the fixed wall. Okay. All right. Let me make that thing orange. Okay, let's go make it. Double click on that vertical plane. I will sketch. I'll sketch something like that. Let me dimension this thing to be on this side also 0.1 and 0.1 here. Exit. And then I'm going to pad this thing. Let me see, is that the right direction? In the other direction. And yeah, that's good. So this is going to be my fixed wall. And while I'm at it, let me create a point at the center of gravity, the centroid of that face, because that's where we're going to put our spring, attach our spring to. So it's going to center of gravity, select the face, and it's going to put a center of point at the center of mass or centroid of that face. Now we're going to go and insert our other part, 3D part, and I'm going to call this thing the mass or the block. Call it block and block. All right, let's go make it. Double click on that same vertical plane. I will sketch another rectangle of that side. Of course, what you can do if you want, you can project that to make your job easier. Project this. Okay, and exit instead of drawing it and constraining it. And then I'm going to pad it by 0.1 meter. There we are. We also change the color of this thing to green. I like green. All right. So what I like to do is to move that green 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 block by half a meter. So I'm in the assembly. Use the compass. You select the compass, put it on this face, and then click on the this arrow. And what you want to do is already the block has a length of 0.1 and a separation of 0.5, so that's 0.6. And okay, there we are. So notice that the green block has been moved 0.5 meter away from that face. Okay, and then close it. We're done with that. Okay, good. Now we can apply our constraints. So assembly, let's fix the fixed wall, and then we create a prismatic joint. Between this. I use this last template. It really doesn't matter. So yeah, between this edge, the edge of that orange piece, and this edge, and that face, and this face. And I really don't need these last two boxes, so I just delete it. And then we say OK. So we have created a prismatic joint. You'll see that right there. And one other thing I want to do is I want to create a point at the at the centroid of this face, because later on we're going to put the spring on it. Now to do that, I'll go to the block, double click on 3D shape for the block, and create a point, and the centroid or center of gravity of this. The point has been created here. You can see that. Good, good. We're done. So now we're going to go to motion design. I'm going to create a new mechanism. A couple of things you should notice is that there is if you go to global, gravity is activated by default. So I'm going to deactivate this. Don't want gravity. And then when you go to bodies, what it does, it assigns default material properties of steel on this. Now, for example, for the fixed ball, if you double click on it, actually, I don't need it to be made of steel. It's fixed anyway. It makes absolutely no difference. So if I insist on that, I can make this thing rigid massless. But I'll leave it the way it is. No problem. And if you double click on the block, it uses the default properties of steel and it gives you that value. But I don't want that thing. I want my mass to be 40. So pull this thing down, the pull down menu, and override the mass property. So just put down 40 here because the statement of the problem says it's 40. And then we say OK. Good. So now we're going to go to machine elements. Here's the spring, helical spring. Okay, not torsional one, helical one. Between this point that I created, that centroid, and the centroid of this other face that I created. Okay. Right now, the distance of it is 0.5, and I want the free length to be 0.5, so that's 0.5. And the stiffness spring rate is 100. I already put 100 in there. And damping, I want 0 at this point. This is damping. Say OK. So there is a spring that has been created right there. Right there. Good. You can see that. Yeah. Okay, now we're going to go to apply a force. So mechanism, let's find the force, applied load, and I'm going to apply it to that point, same point, in the direction X 100 newtons. And that's pretty much it. Okay, very good. I don't think I forgot anything, so let's go ahead and well, first of all, we can have a preview here. There's the preview. This is not running yet, but just a preview. Hopefully it will work. Yeah. Okay. That's fine. This is exactly what it's supposed to do. Let's exit. And now we're going to go to simulation and run it. Wait until it says succeeded. And first of all, if you want to see the animation, you go here, select the dynamic step 1 results, and go to results. And here is play animation. And let's play it. Okay, I don't know what the duration of my analysis was, whether it was 10 or whether it was 5. Let me see, what did I have here? 10. Okay, so all right, that's fine. I didn't do that because if you go to this analysis step, dynamic step 1, the default is 5, so it took 5 seconds. So I'll just leave it the way it is, no problem. I'll do it over 5 seconds. Now for plots, let's plot the block and the X position of the block. And if you check, this goes between roughly 0.5 to roughly 2.4, and that's exactly matches this, roughly 0.5 to 2.4, pretty much. And the duration is the time period is almost 4 seconds. And if you look at it from here to that peak is also almost this is half. This is half the period, 2 seconds. So almost double it. You get basically trough to trough is about 3.95. Very good. Now, if you look at if you want to put damping there now, so go to that helical spring, double click, and make sure the damping information is shown. Put a 10. Oops. And change it. It's still 0. 10. 10. Say OK. And now run it again. Wait until it finishes, and it did. So go to select the results, and results, animation. Notice that the amplitude decreases. You can see that the amplitude decreases. And it's kind of hard to see it in this plot. So let's go to 2D plot. Once again, block and X position, the amplitude decreases. There we are. If we do it over 10 seconds, we can see it better. So actually, let's go and do it over 10 seconds. So we go to dynamic step, put a 10, say OK, and then run it. It's easier to see what's going on here. It's done. So go to results, plot, and select the block and X position, add to the plot, and you can see that it goes up to this height, which is roughly 1.76, and that agrees with this plot. Roughly 1.76 is around 1.76 after 10 seconds. Okay, so that's pretty much it. Notice that I did not specify any initial conditions here. The spring was unstretched. There are no initial conditions. Therefore, in one of the tutorials, I'll come back and show you how to apply initial conditions later on. Good luck.